Exercise 76, question number 12. We've got to find the angle of lap, theta, in this diagram as I've drawn it out here, for a pulley that's in contact with a drive belt. And the angle of lap, which is the lap of the drive belt that's in contact with the pulley, is the actual amount of distance that's where the pulley is in contact with the belt, as I've drawn here. So there's 180 millimeters of belt in contact with the pulley, and we've got to find out the angle of lap. So really, that 180 millimeters is the arc length of the circle that we're interested here, S. So S equals 188 millimeters. We're given the diameter of the pulley, so we can find the radius of this particular sector, where theta is the angle of lap. So we can find theta, and then just make sure that's in degrees and minutes. So you can have a go at that, and I will go through the solution now. So the formula that's involved to start off with is that S equals R theta, and we're after theta, so theta equals S over R, dividing both sides by R. I know S and I know R, so R equals a half of 250, which is 125 millimeters. So now I can put those values in, and I'll get that theta equals 180 divided by 125, and that will give me the angle in radians. Then I need to remember to convert that to degrees. So to get that to degrees, I remember that 360 degrees is 2 pi radians, so therefore 180 degrees is pi radians. I want to know what radians is in degrees, so I need to know what 1 radian is, so therefore 1 radian equals 180 divided by pi. So what's my theta in this particular case? Therefore theta equals 180 over 125, which is my angle in radians, times by 180 over pi. So if I work that out, that'll give my angle, but that angle will be in fractions of a degree, and I want it in degrees and minutes. So if I work out what that is in degrees, so theta is 82.51 degrees. But we want it in degrees and minutes, so 60 minutes in a degree. 60 minutes equals 1 degree. Like time, there's 60 minutes in an hour, 60 minutes in a degree, and we can also actually divide angles into seconds as well. There's 60 seconds in a minute. Same sort of idea as time. So what I want to do now is convert the 0.51 degrees into minutes. So basically what I do is I think to myself, okay, 0.51 is actually 51 hundredths of a degree, and we want to know what that is in 60ths, i.e. in minutes. So I actually times both sides by 60, and I get x equals 51 over 100 times by 60. That's the sort of idea. So in other words, what we do is, to get the angle in minutes, I just times my angle as a decimal by 60 to get it to minutes. So you just take your 0.51 times that by 60, and you get the minutes, and you should then get the answer in the textbook. But we don't often worry too much about degrees and minutes nowadays. 82.51 degrees will probably be fine.